an AP class, it is expected that you will take the AP exam. So look out for the form for you to sign up for that. You're allowed, this is one of the classes you can take for free. There's two STEM classes that you can take for free. This AP class or math, if you're going to do the math, if you're doing math. So you have to choose between one. You're allowed one free STEM class. And so this counts as one of them. So it wouldn't hurt to take the exam, but you got to sign up for it, and you have to sign up for it soon. I think by the 17th. So be on the lookout for that letter. You do have to indicate whether you're declining to take the exam. So one way or the other, you have to let Miss Martin know that you're going to take it or not take it. So look out for that form. And again, what was I going to say? It's free. It wouldn't hurt to take it. We are, and I just want to remind you too that when you're answering the FRQs, answer them with as much vocabulary words as you can, because they need to understand that you are understanding how to use the vocabulary words correctly. All right, that being said, all of the preliminaries, okay, I might need to say that again. We got a couple of people, 3 people who just joined. Good afternoon, good afternoon, good afternoon. Danian, I got your message. Okay. All righty. All right. If you just joined, I was explaining that soon you'll get a letter about signing up for the AP exam. If you're not doing, if this is the only STEM class that you're taking, math, science, engineering, and technology, then this class would be free. So it wouldn't hurt for you to venture out and take that exam anyway. All right, we're going to look at phosphorus today. I know some of you are still working on the other, so I'm just going to start this and then give you the chance to go back and do what you need to do as far as finishing up, because it is Friday, so you need to work on finishing up anything that's outstanding. All right, so again, we're doing cycles. And so you would want to look at the cycle. And when we're finished with this, we'll take a quick look at what it looks like in Canvas. But it is element that is necessary for living things, is basically the understanding that you need to have with all of these carbon and nitrogen, and now we're doing phosphorus. So you need to understand where we're getting these elements from, why we need them, and how they are cycled over and over again. Because remember, nothing is created or destroyed. Everything that's on the planet is on the planet, and we just keep reusing it. But this is how you need to know how it's reused every time. All righty, Mr. Sneed is going to talk to you for a few.
Today we'll be covering topic 1.6, which is the phosphorus cycle. Just like with the carbon cycle and the nitrogen cycle, we'll be talking about how phosphorus moves between sources and sinks, but we'll also be making some comparisons between the carbon cycle and the nitrogen cycle as we go through the phosphorus cycle today. Our objective today is to be able to explain the steps and reservoir interactions in the phosphorus cycle, and the skill we'll practice at the end of the video is the one that we've been practicing the past couple days, which is explaining relationships between characteristics of an environmental concept in a visual model setting. So just like in the carbon cycle and the nitrogen cycle, the phosphorus cycle is the movement of phosphorus-containing elements between sources and sinks. So the two major reservoirs of phosphorus are rocks and phosphorus-containing sediments. So if we look at the diagram here, we can see rocks that could be found in mountains or really in any ecosystem contain phosphorus in them, and also sediments at the bottom of bodies of water or even sediments found in soil.
Imagine being able to build an app with your name on it, just by thinking about it. Meet Base 44, a complete...
Imagine having no
An
commercials.
important point to know is that the phosphorus cycle is extremely slow when compared to the carbon cycle and nitrogen cycle. This is for a couple reasons, which we'll talk about now. So the first one is that the two main reservoirs of phosphorus, which again are rocks and sediments, release phosphorus very slowly. It's a process called weathering, where wind and rain break down the rock and release phosphorus in a form called phosphate. So that phosphate then has to be washed away from that rock or those sediments and into either aquatic ecosystems or into soil on land. So that process takes a long time. Another reason that this is such a slow process is there's no gas form of phosphorus on Earth. And so what that means is that phosphorus has to be moving in this solid form in phosphate, which has to be weathered from rocks and carried by water. And that's just really slow. So when we compare that again to the nitrogen carbon cycles, there are gas phases of both of those cycles, which move faster. Then finally, an important point to understand is that because phosphorus cycles so slowly, it's often a limiting nutrient in ecosystems. So because it takes so long for the rocks to be weathered and for them to release their phosphorus, which is then carried through runoff into either bodies of water or into soil, that's a really slow process, and organisms therefore have less access to phosphorus. Now, all organisms need phosphorus because it's a key element in ATP, which is an energy source for every living thing, in DNA, and then for many animals, it's a source of strength for their bones and for the enamel in their teeth. Now we'll talk about both natural and synthetic sources of phosphorus. So the major natural source of phosphorus is the weathering of phosphorus-containing rocks by the wind and the rain. So the wind and the rain beat down on these rocks over time, breaking them into smaller bits, which results in the release of phosphate from these rocks. The phosphate then dissolves into the rainwater, and it's washed either into aquatic ecosystems or into terrestrial ecosystems, so into the soil in an area. So you can see this here in the diagram if we look at this big green circle. Again, the phosphates are worn down from those rocks, and then the wind and the rain will carry them either into a body of water or into a terrestrial ecosystem. It's important to remember that this process is very slow, and because of that, phosphorus is a limiting nutrient in many different ecosystems, meaning plant growth is dependent on how much phosphorus is available. In terms of synthetic or human-made sources of phosphorus, humans mine phosphate-containing rocks out of the ground, and then they add phosphates to either synthetic fertilizers or other products like detergents and cleaners. So we can see this diagram here. We'll dig up rocks that contain phosphorus, take out the phosphorus, and add phosphates to these products such as fertilizers or detergents. So this creates an issue because when we have runoff from agricultural fields, it can carry the phosphates that were in the soil into nearby bodies of water. The same thing can happen if we're talking about detergents and cleaners, because those can leave homes via their wastewater, and the phosphates in those detergents and cleaners can eventually enter natural bodies of water. Just like nitrogen, phosphorus is absorbed from the soil by plants' roots, and it's assimilated into plant tissues. Animals, just like in the nitrogen cycle, have to eat plants to take in phosphorus to their bodies or eat other animals that have eaten plants. Then we also have the excretion of animal waste or the decomposition of dead organic matter by soil bacteria and decomposers, and that's going to return phosphorus to the soil. So just like in the nitrogen cycle, we have this mini loop that's formed here where we have assimilation of phosphorus into plants, and then we have animals that eat those plants to take the phosphorus into their bodies. When the animals and plants die, that phosphorus is returned to the soil by decomposition, just like in the nitrogen cycle. Next, we'll talk about sedimentation and geological uplift. So phosphorus does not dissolve super well into water, which means that much of it precipitates out or forms solid phosphate sediments at the bottom of a body of water. Think about when you make Kool-Aid and you add too much sugar. The water can only hold so much of that sugar, so a lot of it forms crystallized sugar at the bottom that you can actually see. And so this is similar to the way that phosphate will precipitate out of a water source. And we call this act sedimentation, so the act of forming phosphate sediments at the bottom of a body of water. Over time, what we can see is that the weight of the water above those phosphate-containing sediments will compress those sediments into sedimentary rock, like limestone or sandstone. Geological uplift, then, is the process where tectonic plates collide and force new rock layers up to form mountains. So this allows new rock to be exposed to the elements like wind and rain, which then starts the weathering of phosphorus, and we're basically back at the beginning of the cycle.
Yeah, you got it.
Progressive's Up Payment program provides down payment assistance for first-generation home buyers.
And lastly, today we'll talk about a problem called eutrophication, which results when a body of water receives too much nitrogen and phosphorus.
All right, I'm pausing it there because this is a vocabulary word that you need to be particularly familiar with. So you might want to write it down.
So because these elements are usually so limited, having extra inputs of nitrogen or phosphorus can lead to eutrophication, which literally means excess growth or excess nutrients. And this can in turn lead to an algae growth or an algae bloom that covers up the surface of the water. Now, these nitrogen inputs can often come from things like synthetic fertilizers that are applied to lawns or agricultural fields, or when a body of water becomes contaminated with waste from humans or waste from animals. Because this waste is an organic compound, they often contain both phosphorus and nitrogen. So because the surface of the water is covered by these algae, that blocks the sunlight from reaching the plants below the surface of the water, and those plants die. The algae themselves eventually die off, and then the bacteria in the water use up oxygen to break down the algae and the other dead plants. The reason that they use up the oxygen is because decomposition is an aerobic process, so it requires them to use oxygen. This loss of oxygen, as the bacteria use it up, results in the death of other aquatic species, especially larger fish species that have high oxygen requirements. Then the bacteria break down those dead organisms, and that uses up even more oxygen. So pretty quickly, we have something called a positive feedback loop. Positive feedback loop is where the outcome of the process drives the process to continue forward at an even faster
I'm gonna hold
rate.
it right there as well. That's another point that you need to be familiar with. Positive feedback loop. What does that mean? So I'm gonna back it up just a little bit so that you can listen to that discussion.
We have something called a positive feedback loop. Positive feedback loop is where the outcome of the process drives the process to continue forward at an even faster rate. So as we have less oxygen, we have more organisms die, which results in more bacteria breaking down those dead bodies, using up even more oxygen. And you can see how this quickly spirals out of control to create something called a dead zone, where the water contains such little oxygen that virtually no life can be supported there anymore. Our practice FRQ for topic 1.6 today will involve the skill of using a visual model to explain relationships between different characteristics of an environmental concept. So I want you to look at this model and choose two reservoirs that are shown in the model. Then I want you to describe how phosphorus moves between those two reservoirs.
Alrighty.
All right, everybody.
So I'll put that FRQ up later. Right now I'm checking the last one that y'all did. So hold on. So what I need you to do right now is go ahead and log into your AP classroom. But before you do that, finish up anything that you have not already finished. So right now in the AP classroom, 1.6 has been assigned. So if you have completed everything else, then you need to go ahead and do that. But I do still have, like I said last time, that there's about 7 of y'all who have not completed your Gizmo activity. So I'm closing that out today. So after today, you'll have to ask me to check it. So make sure that you not only turn on the worksheet, because the worksheet, some of y'all saw the answers to that anyway, so that's kind of not a big deal. The big deal is the questions that you answered while you were doing the gizmo itself. So that's a score out of 43. So I need that score to go with the worksheet score to put in the book, the Canvas today. So please wrap that up. And anything else that you might have missing, because I am closing out grades today for this week. The end of 9 weeks comes up for you all. There is a 9-week test. There is a 9-week test. And for you, it is September 30th. That's when second and sixth period exams are on September 30th. So we will do, let me pull up my AP Classroom. It will be in the AP Classroom. So it is an AP Classroom exam. It will have multiple choice. And so we'll have MCQs and FRQs. So this is why we've been practicing doing the FRQs, because the exam, it's very slow. Okay. All right, so our objective next week is to finish doing the cycles and and we're only on 6 and 7, so we need to get through, well, we may not get through trophic levels, but at least finish the cycles next week. All of the cycles. So that's phosphorus and the water cycle and trophic levels. The 10% rule isn't that big. Food webs and food chains. You might have had those in biology already. So yeah, we can get this done. We can get this done next week. So we got a lot to do next week. Progress check is what the exam is called. So the progress check is what we're shooting for. And if we don't get to 1 or 2 of these, I will have to just eliminate that particular question from the progress check. But if you're going to review all of Unit 1 for September 30th, because that's going to be the end of 9 weeks test. Okay. All righty. And so again, phosphorus has been assigned, like water has already been assigned as well. That was assigned before. Some 1 or 2 of you have done that, but go ahead and do phosphorus if you've completed all your other assignments. And water. The water cycle is pretty straightforward. Most of you have done that since kindergarten. So you know your water cycle. The difference with the water cycle now is we have some extra vocabulary stuck in there. So like everything else, you need to know what stages the water is in when it's moving and where it's stored. So it's all about reservoir and source, always with each of these cycles. All right, I am going to stop talking so that you can get to whatever it is you need to get to. Again, please finish the gizmo first. If you have not done that, like I said, after today, I'm going to stop asking and I'm going to put the grade in as is. So if you have not completed the gizmo, and like I said, about 7 of you have not. 7 exactly. Please give that your attention first. If you have completed that, then you need to, and I think everybody's turned in their case study. And I had wanted to do a gallery walk with that, but I don't think we're going to have time to do that at this point. We can do that after the exam. That's a Wednesday thing. There are no exams on Wednesday, so we can do the gallery walk on that Wednesday. Alrighty. If you have any questions, please ask. Oh, that's not this class. That's the other class. Oh, that's this class. Yeah. We finished with that. So no gallery walk. We did a gallery walk already. I have another class that has not done their gallery walk yet. I might not, but you have. All right, so go ahead and do the FOSS, the 1.6. I won't put it in the grade book until next week, so that won't come up as something that's missing this week. I have to make phone calls, and praise the Lord, I don't have to call anybody's house in this class. Y'all are doing great. Excellent, excellent. Keep up the good work. All righty. But again, please make note of the fact that exams are the week of the 29th. So your other teachers should be, if they haven't already told you, should be telling you about exam dates. Not every teacher has to give an exam. I have to give one because you are a test. All AP classes have to have an exam. So we are having one. And just a heads up that all of your exams of that size will be the progress check in the AP classroom. So it'll be an AP formatted exam always. All right, so I've only got 5 worksheets for the nitrogen, so most of you need to do that first, please, and then do the nitrogen questions. I mean, the phosphorus questions. think I need- Brooklyn, I will look at that. The only time I have to grade it is if it's an FRQ. Then yes, it will not self-grade. Give me 1 second. Record. Which one specifically are you talking about, Brooklyn? Okay. Yeah, the ones I've assigned, they should all self-grade. It may take a minute. I think the computer is glitching. And why is the phosphorus one before nitrogen? Hmm. Score not even a thing. Okay, folks, time is up. I'm going to stay on because this is also tutorial time for me. So I'll be still logged in until 2 o'clock, but you all are free to log out. If you need, I got somebody logging in already, I guess, for a tutorial. So have a good weekend and see you next week. Finish up anything you need to finish up. Okay. Where's it all going?